I'm Ashley. I'm got a background in robotics. I sort of started out developing self-driving cars at Oxford during my PhD, and then moved into developing drones that survey difficult situations in the nuclear industry, which got deployed at Fukushima. I sort of realized that the interesting part of my job wasn't necessarily the robots itself, it was all of the data we got to use and understand and play with. And for that, Pupil is the best. We get to play with one of the biggest geospatial datasets in the world every single day. The Dollhouse product brings together lots and lots of different technologies, and these all happen in the background in our data pipelines. So the customer, in the end, all they should see is a beautiful model of their property delivered to their inbox. They don't need to care about all the smarts in the background, they're just meant to work. What the technology we've developed allows us to do is take these big long lists of numbers, basically, which is a survey. It's just a list of X, Y, Z positions, which by themselves are completely meaningless. It's just raw data. And we've developed algorithms to understand this data and turn it into useful information. So figuring out in that big long list, where are the walls, where are the sofas, where are the potted plants, all those different things. So when we're actually building our 3D model, we have what's called a semantic understanding of the data, and we can use that to inform our meshing algorithms to make the mesh look as realistic and beautiful as possible. So say, for example, if we're reconstructing walls, we want to treat those differently to a very complex object like a potted plant. And that's some of the smarts that we're developing to allow us to do that. So I think the main thing that sets our Dollhouse apart from other Dollhouses in the market is actually the way we collect the data. So we don't just collect scans from a LiDAR scanner, we collect scans and imagery from photosphere cameras, which produce really beautiful imagery. This allows us to fuse that really accurate 3D data from the point clouds with the really beautiful data from the photospheres into a final mesh.